Hi, hello everyone. Welcome to this course called Problem Solving and Programming in C. This is the first lecture of the course, and the title of the lecture is Introduction to Computers and Programming. In this lecture, we will learn what is a computer, what are different parts of computer, and how they communicate with each other to solve a computational problem. We will learn what is a program, what is a programming language, how the programming languages are evolved over time. We will see what is machine language, how machine language programs are executed. We will see a couple of sample machine language programs. We will see how a machine language program is executed by the computer. And we will also see a sample assembly language program and a C program, which is a high-level programming language. What is a computer? Computer is an electronic device that can store data, takes data as input, process the data according to the instructions that are provided by computer programs, and provides or display output or information. This definition will give a glimpse of different features of the computer. Computer has a memory where it stores the data. That is one of the feature of the computer. And then when you have a program, any computer program takes input some data. The data can be taken from the memory or it can be taken from the input device also. And the program processes this data and then gives a meaningful information. The output can be in the form of a display in the display device, or it can be a printout, or it can be saved into a file which goes to the memory again. Okay. So what is this data? Data can be a number, it can be a name of a person, it can be an email ID, or it can be mobile number, or it can be an image, or it can be a movie file. So these are all different kinds of data. So any computer program basically takes input as data, process it, and gives some meaningful information. Okay. Uh, we are all familiar with computer. Most of you have seen the computer, I suppose. Then let us try to understand what is the basic difference between calculator and a computer. What concept has revolutionized the computer? Okay, it is the concept of stored program. What is a stored program? The ability to store a program in computer memory and run it with different kinds of inputs. This concept, which is introduced by John von Neumann, has revolutionized the computer. Then um, uh, you can see in which stage computers are there right now. Okay, computers has revolutionized the world. Then um, they are very much part of our life and important in our day-to-day activities. So let us see what are different parts of computer. So you can look at the image on the right side. Um, Basically, you have input devices, output devices, memory devices, and then there is a central processing unit. Central processing unit. So input devices basically keyboard. What are the input devices? Keyboard, mouse, camera, microphone, scanner. All these are kind of input devices. What are the output devices? Monitor, where you see the display, speakers, and printer. These are all different kinds of output devices. The central processing unit, which is responsible for performing computational computations. So it has a lot of uh, subunits. One is arithmetical logical unit, which is responsible for performing arithmetic operations and logical operations. Control unit, which is responsible for controlling different devices. Then it has also cache memory, and it has a lot of registers which will help in executing a machine language program. Okay, and all input devices are connected together. For example, the central processing unit is connected to main memory in turn connected to secondary storage device. So whenever you are trying to execute a program, that program is originally stored residing in the secondary storage device, but it will be brought into the main memory. From then on, the main memory, the central processing unit uses that program, and then executes the program. During the executions, it uses registers and the cache memory and all other subunits to perform a particular computational task. So other parts of the computer, primary memory. Primary memory, you can see two kinds of primary memory: random access memory, RAM. This is called main memory. Read-only memory. So this is where some important programs which are responsible for loading your operating system will be stored in this memory. Then we have secondary storage devices, hard disk, USB devices, CDs, DVDs, etc. And we have motherboard. Motherboard is basically it's a board where all these devices are placed. For example, central processing is CPU, um, primary memory, secondary memory, hard disk. These are all placed in the motherboard. And then you have a bus which connects. Bus is basically a cabling mechanism which connects these different devices. So what is a computer program? A computer program is a sequence of instructions written by following syntactic requirements of a programming language to solve a particular task. Using computer programs, we communicate with hardware to perform specific tasks. So what is a program? It's a sequence of instructions. And written in a programming language. Every programming language has a syntactic rules and regulations. Okay, using those syntactic rules only we can write the programs. What is a programming language? Any language, if you take English language or any language, every language has some vocabulary and some grammatical rules to form sentences and paragraphs, right? So like that, computer programming languages also has a vocabulary. Programming language is basically a vocabulary and a set of grammatical rules to instruct a computer to perform a specific task. We create computer programs following the syntactic rules of the programming language. Every programming language has a syntactic rules. Following them, we write computer programs. What is machine language? Machine language is a low-level programming language that is understood by computers. Computer understands only machine language. The machine language, all the code is written in binary language. It uses only bits, zeros and ones. Machine language has a instruction size and instruction format. Okay. Suppose if instruction size is 32 bits, so within that 32 bit, you will see some portion of the instruction is given to the operation code, and the remaining portion is given to the operand. Okay. So the machine language uses binary instruction codes to perform operation. For each operation, you have a specific code. So since the machine language uses only bits, zeros and ones, machine language instructions or machine language programs are hard to understand or create. Let us see how the programming languages have evolved over time. As I told, initially, computers programming language started with machine language. Okay, and this is the only language which computers understand directly. The machine language uses only bits, and we have instruction codes to perform different operations. Then, since the machine language is hard to program and hard to understand, people invented assembly language. Assembly language, what is the difference between assembly language and machine language? In assembly language, instead of binary values for the key for the operation codes, it uses mnemonics or keywords. Okay, each operation has given a specific mnemonic. Using that, you write the assembly language programs. Assembly language programs are easier to read and understand compared to machine language, but they are still harder to create and understand. So see, as I told you, computer understands only machine language. Even though you're writing assembly language program, the assembly language program should eventually be converted to machine language, um, so that the computer can execute it. So that is why there is a something called assembler. Assembler is a computer program which takes an assembly language program as input and creates a machine language program which is equivalent of the assembly language program. For example, x86 assembly language program is an example assembly language. So then the third level of programming languages is high level programming languages like C, C++, Java, Pascal, Python. Okay. So the programming language we are going to learn this course is C, which comes under high level programming languages. Okay. As I told you, computers understands only machine language. Even though you are writing a program in high level programming languages like C or C++, there should be someone to convert it to a machine language. That is the duty of compiler and interpreter. Compiler and interpreters are a computer programs which takes high level programs as input and uh, converts the high level program to machine language program. And what is the difference between compiler and interpreter? Compiler basically takes the entire program and converts the entire program to machine language program. Whereas an interpreter, it takes one line of the high level program and converts that one line to a machine language. So that is the difference between compiler and an interpreter. The fourth level of programming languages is very high level programming languages. They are basically scripting or and query languages. So they are goal oriented in a sense. There is more emphasis on what to do than how to do. Okay, there are already a lot of existing constructs will be there. We just need to worry about what we want based on that. How to do is will be handled by the language itself. For example language, query language is Perl, and scripting language is Perl, and query language is SQL. Suppose if you want to get an information from a database, okay, then you just write a query. How to execute the query and how to extract the information from the database is handled by the query language itself. So that is why the emphasis on more on what to do than how to do. Then fifth and last level of programming languages are natural languages. Uh, Basically, the idea is, suppose if one person sitting in front of a computer talks in his own language, what he wants from the computer understands and perform those tasks. Okay, perform those tasks, then that is called natural language. So it is natural language. Basically, it is the ability of the computer to understand human languages. So where natural language processing come into picture. Natural language processing is basically computer able to understand the natural languages, and also artificial intelligence also come into picture here. Okay, because um, a computer needs to understand the human language and should be able to take its own decisions and perform tasks. Okay. So natural languages, the artificial intelligence is a growing area of research. Then already we have ChatGPT and all, which are artificial models. Okay, right. So this is a growing field of research. Let us understand uh, how machine language, what is a machine language program and how machine language programs are executed. Okay, machine language program is basically a sequence of bytes. Okay, or sequence of instruction. Each instruction has a specific size. For example, you take instruction size as 32 bit. Okay, so you will have a set of a sequence of instructions. Each instruction is of 32 bits. Within the instruction has a format. What is that format? What is its size? What is the size of the operation code, and what is the size of the operand? For example, if the instruction size is 32 bit, um, the operation code can take 6 bits, and operand can take 26 bits. Okay, that is one kind of partitioning, right? So operation code will tell about how what operation to be performed. Operand will tell on where to get the data to perform the operation. Okay, from which register to get the data from the operand, or which location of the memory to get the data from the operand for the operator. Right. What is the role of registers? As I told you, central processing in CPU, central processing unit, consists of a lot of registers. Okay, they all help in executing the machine language program. So, for example, there is something called program counter. It's a register which contains the address of the next instruction to be executed. Suppose if you are executing a particular instruction, what is the next instruction? Okay, so it contains the address of the next instruction. Accumulator is basically a register. It used to store intermediate results of arithmetic or logical operation. Okay. Instruction register. It contains the current instruction that is currently being executed. Though you read instruction register, if you read the instruction register and the split get the operation code, then operand, then the CPU will execute the particular instruction. Memory address register. This register contains the memory address of the data. Memory data register contains data that is being fetched from the memory. And the CPU also contains quite a few general purpose registers. These are additional registers that are present in the CPU, which are used for either memory address or data based on the requirement. Condition code register. And this register contains the status of the condition of the previous result from the arithmetic logic unit. For example, you have made comparison. You want to, if there is some other, there is some overflow, or there is some division by zero operations, all those things will be stored in flags will be set in this register. So let us see what is the role of different parts of the computer in executing the machine language programs. The role of main memory. So basically, your program, when your program is stored in the secondary storage device like hard disk or pen drive, USB drives, when you're trying to execute your program, the program will be brought into the main memory. What is a main memory? Main memory is a sequence of bytes. So it holds the program under execution as well as the data. When you are trying to execute a program, the program is brought into the main memory, and also the main memory. Some portion of the main memory will also be given to the program for the purpose of storing and retrieving data. Okay. So what is the role of cache memory? Cache memory is memory is attached to the central processing unit, and which is closer to the CPU, and it is faster memory that stores frequently accessed data and instructions. As I told you, when you're trying to execute a when you're trying to execute a program, program is brought into the main memory. From there, instructions are fetched. So communicating to the main memory is a time-taking process. The communication between the CPU and main memory is a time-taking process. That is why if we have a faster memory, that will improve the running time of the program. So that's why we have a cache memory. It contains frequently used or previously used data or instructions. when CPU is looking for some data, it will first check in the cache memory. If it is already there in the cache memory, it will use from the cache memory. It will retrieve from the cache memory. If it is not already there, it will go to the main memory and fetch that particular data to the cache memory, and then from then it will use that particular data. Okay. Also, there are a lot of instructions. There are instruction to add, instruction to subtract, instruction to multiply, instruction to increment, mm, instruction to decrement, and also there is a special instruction called jump instruction. What happens is when you are doing a programming, you want to do some task repeatedly, or you want to execute some set of statement based on condition. So there you cannot always go execute instructions sequentially. You have to go maybe backwards, or you may have to go to jump forward. So that is why the next instruction to be this jump instruction will help you to um, replicate the repetition and selection statements. Okay. Now we will see a sample machine language program, because to understand the difficulty in writing machine language programs or understanding machine language program, we should look at some sample machine language programs. Okay. And we should understand why the need for high level programming languages. Okay. So now I will show a couple of machine language programs for adding two numbers, and another problem is computing factorial of a number. Okay, so this is a sample machine language program. So as I told, it is sample. The original instruction sizes, operation codes may be different. This machine language program is only for the purpose of understanding how machine language programs are written and executed. Okay. So this program is for machine language program. You will only see zeros and ones. You will not be able to just looking at the program. You will not get any idea on what the program is trying to do. Okay. And also it's very difficult to write such programs. It's a time consuming process. So in this given sample machine language program, the instruction size is 16 bits, and 4 bits are allocated for the assigned for the operation code, and 12 bits allocated for the operation. Okay. Let us try to decode what this program is trying to do. Yes. This on the left side, you have on the left side you have on the left side on the so you see this is the instruction size. As I told you, the machine language program, the program is stored in the primary memory. So this is the location. This is the location of where this instruction is stored in the primary memory, A00. So this is the decimal number. 2560 is the decimal number of the memory location where this instruction is stored. This is the hexadecimal value. Hexadecimal is basically like decimal is base 10, right? Hexadecimal is base 60. Usually memory locations and mm, are represented in hexadecimal because they are shorter in notation. Okay, this is the instruction. Then this is instruction in hexadecimal. For example, this 4 bits is 2. This 4 bits is A. This 4 bits is 0. This 4 bits are 4. And then what is the meaning of this instruction? Meaning of this instruction is load A04. Okay, load A04. Okay, so load A04. What it does is that the data present in the location A04 will be loaded to the accumulator. There is something called, you have a program counter. You have program counter, you have accumulator. Okay. Load instruction means this whatever the data available at location A04 will be stored into the accumulator, register accumulator. Okay, and then add A04, add A04, add A04. Add A04 means what is there in A04 register A04. This will be this number, this data will be added to the already value present in the accumulator. So if this is A, this value is A. So we are trying to add, this is already in the accumulator. If we add this to the accumulator, we are doing a B. Suppose this is A, this is B. So we are trying to add A plus B. So store A06. Store means it will store the whatever the result which is already there in the accumulator will be stored in the location A06. Okay, and then halt. Okay, this is basically performing addition of two numbers. One number is -100, another number is 50. The result will be 50, which will be stored in the location A06. So this is a machine language program to compute factorial number of a number. What is a factorial? Factorial is basically, suppose what is 4 factorial? It is basically 1 into 2 into 3 into 4, which is 24. Similarly, 5 factorial is 1 into 2 into 3 into 4 into 5, which is 120, 120, right? Like that. So this program, this machine language program is written to compute the 4 factorial. Okay. This is the instruction number, this instruction location number, location. These are the instructions, and these are the hexadecimal values of the instruction. This is the assembly language instruction, how a assembly language instruction look like for this machine language instruction. Okay, and then these are the explanation about the instruction. So what it does is, so basically this is 4, this is 4, this is 1. So number 4 is stored in location A08. Number 1 is stored in location A09. Load A09. So 1 will be loaded to accumulator 1, and then you will multiply with A08. So what will happen? A08 you have 4. So 1 into 4 is equal to 4. The accumulator contains 4 now. Store into A09. Store A09. Accumulator value 4 will be stored in A09. So this will be overwritten to 4. Binary equivalent of 4. Next, load A08. Now 4 is loaded into accumulator. These are gone. Then the accumulator 4 is loaded. 4 is loaded. And then decrement. Decrement means this will be performed by -1, which is 3. So now accumulator contains 3. So store A08. This 3 will be written at A08. So this will be now become 3. Will be stored back to location A08. So like this, now you see here, now if there is an instruction called jump instruction. What is this? Jump non-zero. If accumulator value is non-zero. Since current accumulator value is 3, it is non-zero, so it will jump to A0. So jump again from here to here, you will jump. So and again, you will load A09 into accumulator and then perform A09. 4 is loaded into the accumulator. 4 is loaded to the accumulator. And you perform multiplication with 3. 4 into 3, which is 12. And then 12 is again stored here. 12. Like this, it will keep on. So what it's doing is, it is trying to store 4 into 3 into 2 into 1. Then, so this value is getting decremented by 4 becomes 3, 3 becomes 2, 2 becomes 1, 1 becomes 0. When 1 becomes 0, this location A0 becomes 0, then what happens is this jump instruction jump non-zero will be becomes false. Then you will come here. Instead of going to forward jump, you will go to the next instruction only, which is halt. By the time you reach this halt instruction, the this location A09 contains 20. Location A09 contains 24. So that is how factorial of a number. This is a program to machine language program to compute a factorial of a number. Tracing. Okay, this is already done. So factorial of a number. This is a assembly language program to compute a factorial of a number. So you see here, this it uses mnemonics. Load f. There is a variables also. F and f is for factorial, n is for the number. Then load f, multiply n, store f, load n, like this. This is a assembly language program for the to compute a factorial of a number. Compared to machine language program, this is easy to understand, but it is still hard to understand and create programs in machine language. That is why we have a um, um, high-level programming languages. This is a high-level programming language, C program for a computing a factorial of a number. Okay, it doesn't include the input-output statements. This program is to compute a 4 factorial. Okay, so it's easy to, I mean, compared to, let's see, high-level programming languages are more close to how we perform different tasks. Okay, so, and then it uses words like English language like words, English language words. So it is easy to understand and create programs compared to assembly language and machine language programs. Thank you.